Hi, I'm Tomas, and today we will be working on AP Calculus BC question number 4 from the 2017 exam. So this has to do a lot with differential equations and modeling the temperature of a potato. So part A asks us to write an equation for the line tangent to the graph of h at t equals 0. And we're supposed to use this equation to approximate the internal temperature of the potato at time t equals 3. So we're basically supposed to use the fact that a tangent line to a curve can be used to approximate a point on the curve later on. If we don't have the equation for the curve, but we only have a point and the slope, the instantaneous slope of the curve at that point. So first we're going to write out point slope form because that is always the starting point for this sort of a question. So y minus y naught equals m times x minus x naught. However, here we're dealing with h, and we're also dealing with t. So we're going to have to change the point slope form to the appropriate variables. So now that we have our equation written out, we have to find the unknown. So that's h naught, dh dt, t naught. However, h naught we know equals 91, and t naught we know equals 0 because of the point 0, 91 right here. And now we have to evaluate dh dt at time t equals 0 in order to find the slope at the point 0, 91 of the curve. So that's going to be negative 1 over 4 times 91 minus 27, because dh dt in the first place equals negative 1 over 4 times h minus 27. So now our answer comes out to negative 16. So we're able to determine that h minus h naught equals, again, dh dt times t minus t naught. And now we can plug everything in, so h minus 91 equals negative 16 times t minus 0. So h naught just equals, h just equals 91 minus 16t. And if we'd like to approximate h of 3, we plug in 3 for t. So minus 16 times 3, and this yields approximately 43 degrees Celsius. So at time t equals 3, based on the local linearity at the point 0, 91, we can approximate that at time t equals 3, the potato will be 43 degrees Celsius. Now we have to determine if our answer is an underestimate or an overestimate using the second derivative. So it's useful to understand what the second derivative is in terms of the first derivative, and it's simply d dt of dh dt, which equals d squared h over dt squared. And that simply equals d dt of negative 1/4 times h minus 27, and it simply equals negative 1/4. So our second derivative is negative, and this means, this means that h of t is concave down on 0 is less than t, which is less than infinity. So we know that this answer is an overestimate because the second derivative is negative. I'll draw this out for you. Since we have a linear function as our first derivative, we know that, roughly speaking, we're working with a quadratic equation to model the temperature. So let's just say that this is roughly our equation. If we were to draw in a tangent line at time t equals 0, it would look like this. But this would be closer to the actual estimate for the temperature at time t equals 3. Obviously, this is sort of just a rough sketch, but we know that this will be an overestimate merely because the parabola will be concave down the whole time, and a line simply can't account for that. You can even erase this because that's just not really helpful for the application. So now we're going to just explain this. So we come up with this justification. The answer is an overestimate since d squared h dt squared is negative on 0 is less than t, which is less than 3. Okay, now we're going to do part C, which gives us actually a new model for the internal temperature, and we're supposed to find an expression for g of t. So according to this model, negative dg dt equals g minus 27 to the 2/3. First thing we do, separate variables. So the integral of g minus 27 to the 2/3 dg will equal the negative integral of dt on its own. So now, going to integrate, so 3 times g minus 27 to the 1/3 equals negative t plus c. However, we have to find what c equals because we can't just leave c there. And c, this will be the initial value for our equation. So 3 times 91 minus 27 to the 1/3 equals 0 plus c. C, therefore, will equal 12. Does that make sense? Now, what we do, we just plug 12 in for c. And now what we're supposed to do is try to solve for g of t. So we're going to divide each side by 3, leaving us with g minus 27 to the 1/3 equals 4 minus t over 3. And now we're going to cube each side. So g minus 27 equals 4 minus t over 3 cubed. And therefore, g of t equals 27 plus 4 minus t over 3 cubed. And now we're supposed to find g of 3 according to the model. So g of 3 equals 27 plus 4 minus 3 over 3, which is just 1 all cubed. This goes down to 3. So g of 3 equals 27 plus 3 cubed, and therefore g of 3 equals 54 degrees Celsius at time t equals 3. Alright, thank you very much for watching, and I hope that you understand differential equations and potato cooling patterns a lot better now than you did at the beginning of this video.